Hey everyone, welcome back. This is part 4 of lesson 3, and we're going to be talking about logical operations. So, if you remember a few videos back, we had the comparison operators, shown here, and we were using those to compare different values to each other. Using logical operators, we can actually add more parameters to our comparisons and get a little bit more fine detail in our comparisons. So, the first logical operator we're going to go over is the AND operator. This is basically saying that when two conditions are true, you get a true output. When either of those conditions are false, you get a false output. So following this flowchart here, x and y, first it tests x. If x is false, the entire thing gives a false output. If x is true, it goes on to test y. If y is false, you again get a false output. If y is true, then you get a true output because both x and y are true. So going into an example, in oceanography, the relationship between Reynolds numbers and the turbulence of a flow have been well established. The Kármán vortex street, which is what this image is showing here, is estimated to occur when the Reynolds number is between 80 and 200. So if we're given an unknown Reynolds number, we don't even have to know the number. We can test if the Kármán vortex street will occur. So here we have our Reynolds number, RE, and we're going to test if it's greater than 80 and if it's less than 200. If that's true, the Kármán vortex street forms. If not, it doesn't. The next logical operator we're going to go over is OR. So this is basically saying if either condition is true, right? So we have x or y. It goes on to test x. If x is true, the whole thing gets a true output. If x is false, then it moves on to y. And if y is false, then it's a false output because both are false. Or if y is true, then it gets a true output because at least this one is true. Going back to our Reynolds number example here, instead of using an AND, we can use an OR, but we have to say that the Reynolds number is less than 80 or the Reynolds number is greater than 200. If that's false, it means that it's between 80 and 200 and the Kármán vortex street forms. If it's true, it means it's either less than 80 or greater than 200. Fun fact, it can't be both less than 80 and greater than 200. So you couldn't use an AND in this, or you would just never get an answer. Final logical operator that we're going to go over is NOT. This one's a little bit tricky. Basically, it's saying that if this thing is false, the output is true, right? So here we go. We got not x, and it's testing if it's false, we get a true output. If this thing is true, then we get a false output. It's a little bit like opposite day. The last thing I want to talk about is the is operator. This operator tests if two variables refer to the same object. This is really useful when you assign variables to lists. We talked a little bit about how this works when we were talking about the copy function in lists, so we're going to go over it a little bit more in detail. If you assign a variable to a list, it is that list, no matter what. So if you change it, it will still continue to be that list. So here we go. We have a sample list, apples, oranges, and bananas, and we set this variable listVar to this sample list. Now we say listVar is the sample list, and that's true. And even if we change the sample list, so we say sample list.append, so we add something on there, strawberries. Even if we change it, the list variable is still the sample list. In contrast of that, if you assign a variable to a copy of a list, it is not that list. So here we go. We have this sample list, same one, apples, oranges, bananas. And we set this list variable to a sample list.copy. Now, when we compare them using the is operator here, we see that they are not the same object. And again, if you change the sample list and you again compare them, it's still not the same object, and the sample list is changed because you added an object. Finally, if you assign a variable to an identical but separate list, it is also not that list. So we have sample list 1, apples, oranges, and bananas, and we have sample list 2, which is also apples, oranges, and bananas. But then you say sample list 1 is sample list 2, and even though they're exactly the same items in the list, they are not the same list. So sample list 1 is not sample list 2. If you were to put equals equals in, you would actually get a true output. And that's a difference between this is operator and the equals equals comparison operator. That's all we have for today. These were the resources I used to do some of the examples. So the seawater ions, some of the logical operator flow charts, and then looking at the Karman vortex sheet. Have a good rest of your day, and I guess I will see you in class. Thanks for logging on.